Global alert. A giant asteroid could collide with Earth in 2032. Is this the end of the world as we know it? Discover the truth right now. The asteroid has been catalogued at 2024 YR4, an object several hundred meters in diameter, discovered by astronomers in December 2024. According to data from NASA and ESA, it is moving at a speed of over 30,000 kilometers per hour, fast enough to cause a global catastrophe if it were to impact Earth. Key facts. The asteroid belongs to the category of near-Earth objects, NEO, celestial bodies whose orbits bring them close enough to our planet to be closely monitored. Its estimated diameter is several hundred meters, comparable to the size of a skyscraper, meaning an impact could release energy equivalent to millions of tons of TNT. Its speed exceeds 30,000 kilometers per hour, an astonishing figure considering it is approximately 25 times the speed of sound. At this velocity, even a moderately sized asteroid has the potential to cause devastating regional damage or, in extreme cases, impact the global climate. Regarding their composition, asteroids can be rocky, metallic, or a combination of both. Density and internal structure influence the type of damage an impact could cause. Metallic asteroids, for example, are denser and penetrate deeper into the atmosphere, while rocky asteroids may fragment before reaching the surface, generating multiple airburst explosions. Trajectory. The asteroid's orbit is calculated through continuous observations using ground-based and space telescopes. Scientists analyze its position in the sky at different times and use mathematical models to predict its future trajectory. Factors such as the gravity of other celestial bodies, the asteroid's rotation, and the Yarkovsky effect, a small force caused by heat emission, can alter its path over time. To assess the risk of impact, scientists determine close approach windows, which are timeframes when the asteroid will pass near Earth. While most of these objects pose no immediate threat, even small changes in their orbit can make the difference between a safe flyby and a potential collision. Thanks to international collaboration between agencies like NASA and ESA, we closely monitor these objects, improving our ability every day to predict and, if necessary, prevent a planetary catastrophe. Although the headline sounds alarming, scientists use a scale called the Torino scale to assess the actual danger. In this case, the impact risk is 3.1%, based on sources like NASA's JPL, meaning it is extremely unlikely, but not impossible. The Torino scale is a key tool in planetary defense, designed to clearly communicate the threat level posed by an asteroid or comet approaching Earth. This scale ranges from 0 to 10, where 0 indicates no collision risk, and 10 represents a certain impact with catastrophic global consequences. Level 0. No risk. The object is likely to disintegrate in the atmosphere or pass at a great distance. Levels 1 to 3. Very low risk. Events that do not require immediate public attention. Levels 4 to 7. Significant risk. Events that could cause regional damage if an impact occurs. Levels 8 to 10. Certain impact. Devastating effects on a regional or global scale. Most near-Earth objects are classified at level 0. Even those that initially seem more threatening often get downgraded after more detailed studies. Examples of asteroids that once seemed dangerous but turned out not to be: 99942. Apophis. Discovered in 2004, Apophis caused alarm when it was initially classified at level 4 on the Torino scale, with a 2.7% probability of impacting Earth in 2029. However, further observations completely ruled out the risk of collision in the foreseeable future, and it is now classified as level 0. 2004 MN4. Similar to Apophis, this asteroid raised concerns upon its discovery, but after improved orbital measurements, the risk was eliminated. 2010 RF12. This small asteroid initially had a slightly higher probability of impact in 2095, but updated simulations have shown that the threat is practically non-existent. These examples show that, although initial detection may cause alarm, Science and continuous observation allow us to accurately assess the real risk. Constant monitoring is our best defense. If this asteroid were to impact, the consequences would depend on the location of the collision. In the ocean, massive tsunamis. On land, regional devastation, wildfires, and a possible global climate disruption, similar to the extinction of the dinosaurs. An asteroid impact on Earth can trigger catastrophic effects, and the scenario varies depending on whether the impact occurs in water or on land. Ocean impact. Since more than 70% of Earth's surface is covered by water, there is a high probability that an asteroid would fall into the ocean. In this case, the impact would generate massive tsunamis, with waves potentially exceeding 100 meters in height, spreading across vast oceanic regions and causing devastation in coastal areas thousands of kilometers from the epicenter. The energy released could even affect the oceanic crust, triggering secondary earthquakes and altering marine patterns. Impact on land. If the asteroid impacts solid ground, the result would be equally devastating. The initial explosion would release energy equivalent to millions of tons of TNT, generating a shockwave capable of leveling entire cities within a radius of hundreds of kilometers. Massive fires would be inevitable due to the extreme heat, while debris ejected into the atmosphere would create an impact winter, blocking sunlight for months or even years. Long-term climate effects. Regardless of the impact location, the climatic effects could be global. Dust and aerosols injected into the upper atmosphere would reduce the amount of sunlight reaching Earth's surface, causing a drastic drop in temperatures. This global cooling could severely impact agriculture, leading to widespread famine and disrupting ecosystems. In the worst-case scenario, the resulting climate change could last for decades. From colossal tsunamis to prolonged winters, the impact of an asteroid could change the face of our planet in a matter of seconds. That's why preparation and planetary defense are vital for the survival of humanity. The good news: we are not defenseless. NASA and other space agencies are already testing technologies to deflect asteroids. The DART mission, for example, proved that it is possible to change an asteroid's trajectory with a controlled impact. In 2022, NASA conducted a historic experiment, the DART mission, Double Asteroid Redirection Test. This mission was the first full-scale planetary defense test, designed to demonstrate that we can alter the course of a potentially hazardous asteroid through a kinetic impact. DART was launched with the objective of deliberately colliding with Dimorphos, a small moon of the asteroid Didymos. While neither posed a threat to Earth, Dimorphos served as the perfect test lab for this experiment. The impact, which occurred at over 24,000 kilometers per hour, was a resounding success. Although Dimorphos has a diameter of only 160 meters, the force of the collision was enough to alter its orbit around Didymos. The most surprising part? The change was greater than expected. Scientists anticipated a reduction of just a few minutes, but the orbit was shortened by over 30 minutes. This result confirmed that kinetic impact is a viable planetary defense strategy. What does this mean for the future of humanity? The DART mission is just the beginning. Now we know that we can intervene in an asteroid's trajectory if it is detected with enough time. However, direct impact is not the only technology being developed. Several innovative techniques are being explored to deflect asteroids. Gravitational tractors. A massive spacecraft could fly close to an asteroid for a long period, using its own gravity to gradually alter the asteroid's trajectory without requiring a direct impact. Ion thrusters, or attached rockets. Another option is to attach a propulsion system directly to the asteroid, gently pushing it into a new orbit in a controlled manner. Nearby nuclear explosions. Although controversial, this technique involves detonating a nuclear charge near the asteroid's surface. The energy released would vaporize part of the material, generating a thrust force that could change its trajectory. Painting or light reflection techniques. Modifying the asteroid's surface with reflective material could change the amount of sunlight it absorbs and reflects. This would gradually affect its movement due to the Yarkovsky effect. Each of these technologies has its challenges, But the message is clear. With science, international collaboration, and preparation, we can protect our planet from cosmic threats. The DART mission has given us hope. Now the future of planetary defense is in our hands. Although the news may sound terrifying, science is on our side. The risk of an impact in 2032 is very low, but it serves as a reminder of the importance of space surveillance. Humanity is more prepared than ever to face these cosmic challenges. If you enjoyed this journey through the dangers of space, subscribe to Universe Curiosities for more cosmic mysteries.